polynomial function could be as simple as a quadratic, or it could be a little more complicated and have some more hills and valleys, okay? So I'm just going to not necessarily draw anything to scale here, but just make a random polynomial curve, maybe something that looks like that. A couple hills and valleys in there. Now, we know how to find the slope of a line, right? It's rise over run, because on a line, when that slope changes, it changes the same way every time, because the straight line is at the same angle everywhere. I mean, because it's a straight line. This is not a straight line, it's a curve. We've got to be able to find the slope at least on an interval or at a given point along a curve like this, okay? So we can't use our traditional rise over run. So what we're going to do is we're going to say, okay, maybe I want to find the average rate of change, or the slope, from maybe, say, this point A to maybe this point B. So I want to find the average rate of change just on that interval of the function. All right, so if of which you would take A, you would go up to your curve, there would be a point. You'd take your B on your x-axis there, go up, touch your curve. All right, and then if I draw a line through that, that's a secant line, okay, from geometry, if you remember, okay. We've got tangent lines, which we've reviewed this year. Where can I put secant line? Maybe right here, secant line. And now we're reviewing a secant line. So it crosses the curve in 2 points, all right, for a secant line. And if I do the formula for the average rate of change on the interval from A to B, then I will have the slope of that straight line, which is the average of what the slope would be along that curve. Okay, so formula that you have to memorize. Average rate of change. So I'm going to go ARC, average rate of change. All right, and I do kind of want you to think of this as the change in the y's over the change in the x's, because it is going to give me a slope. All right, but our formula, since I have an A to B, an interval from A to B, I'm going to do f of B minus f of A all over B minus A. Okay, so that's the long way. This is the part you're going to memorize, f of B minus f of A over B minus A. That's your average rate of change. But it is going to give me a slope. It's going to give me the slope of that secant line. And in essence, it'll be the change in the y's over the change in the x's when I do it. So the formula is not hard. Got some function notation in there. You're just going to subtract some numbers on the bottom, so the formula is relatively simple. All right, so we good so far? Okay, now, like I said, we're going to streamline this. Okay, so let's see if I can get the example on this half of the piece of paper, and then we'll call it done. All right, let's suppose that they give you a function. All right, so given any type of polynomial curve, we'll go ahead and do a parabola. So f of x is equal to maybe, say, a 3x squared minus a 2x plus a 3. Now, they can ask you, they can give you the interval in interval notation, or they can give you the interval in a sentence format. So I want you to be used to both of those. So for part A, they might say, find the, and I'm going to abbreviate ARC, average rate of change. And they might just say from -2 to 1. All right, so that's what it would look like if they were just going to do it in words. Okay, now let's rewrite underneath that another way you might see it, except I don't necessarily want to do red. I want my answer to be in red, so let's try purple here. Let's say find the average rate of change on the interval from -2 to 1. All right, so they might phrase it something like that. Find the average rate of change on, and then you would need to realize that you're reading that not as an ordered pair, but as an interval, on the interval from -2 to 1. Okay, now our intervals, the first number is always going to be A, the second number is always going to be B. So this is going to be my A value, that's going to be my B value. If it was in words, left to right. The first number they give you is going to be your A. The second number is going to be your B. Okay? So it doesn't matter how they give it to you. So basically, you're just going to crank out that formula. I'm going to write the formula down first since this is the first time we're doing it. F of B minus F of A all over B minus A. All right, and then we know what our B value is. We know what our A value is, so it's a matter of plugging them in. So F of B is going to be F of 1. F of A is going to be F of negative 2. On the bottom, my B is 1. And then I'm subtracting A, which is a negative 2, which is what? It's going to be plus plus. It's going to give us a 3 on the bottom. Okay, so we got a 3 on the bottom. All right, now you're going to plug 1 into the function. The function was given to you up there at the beginning, so this is a little function notation we just got done doing not too long ago. So what's that going to be? 3 minus 2 plus 3 more. What is that like? 4. And then plug in a negative 2. Negative 2 squared is 4 times 3 is going to be a 12. Plus 4 plus 3 more is going to be a negative 19 or a minus 19 there. If I did the math right. Can someone do the math that quick and move their head and check it? Or are you just going to trust me? You're going to trust me. Okay, I think it's right. All right, keep going. Finish out the math. Negative 15 over 3. Average rate of change, negative 5. All right, and that is the slope of the secant line. That would, if I graphed this picture and then I went to the x-axis and went up from my point A and then at negative 2 and then went to 1 along the x-axis and then went up to the curve, put the point and then drew the line through it, that would create a secant line, and that would be the slope of the secant line, all right, along that curve. All right, now after that, because they want you to conceptually see if you understand that, then part B, they're going to ask you to write the equation of the secant line. All right, so we know the slope, so if we can come up with a point on the line, then we're going to be good. All right, so it might say something like find the equation, I'm going to abbreviate here, of the secant line containing, and they're going to give you a couple points. All right, and they're really wanting you to get used to this function notation. So they're going to do something like negative 2 f of negative 2 as a point. And then as the other point, they're going to do 1 f of 1. And the reason they're doing this is they're just trying to get you to be used to this function notation right here. Instead of giving you an ordered pair of negative 2 and then whatever the y value is, they're just saying, okay, well, you can figure out what the y value is if you take negative 2 and plug it into the function. But haven't I already taken negative 2 and plugged it into the function? So they're going to be nice. You did it right there. All right, so then this is really the point, negative 2, 19. Okay, so this is really the point, negative 2, 19. All right, and then same thing here. Instead of just giving you 1 and then what the y value is, they want you to plug 1 into the function, but we already did that. And so we know that's 4. So really that right there is the point, 1, 4. Okay, now if I know the slope and at least 1 point, can I write an equation in point slope form? Okay, so that's what I would recommend. And then I wouldn't change it because it doesn't say in a given form. So I just use point slope form. That's what y minus y1 is equal to the slope and then x minus x1. All right, does it matter which one of those 2 points I use? Doesn't really matter, right? The first one, the second one, whichever one you want. I'm going to use that point. I'm going to use the slope that I calculated in part A. And then I'm going to have opposite on the points when they go in, right? So y minus 19, slope of negative 5, x plus 2, and then don't let me mess this up. Now, if they told you in slope-intercept form, could you FOIL it and move the number over and write it in slope-intercept form? Yes. All right, I don't know what your textbook is going to do. It may tell you to put it in slope-intercept form. Okay, but you're going to start with point slope form because you know the slope and you know a point on that line.